So, if you've seen my last video, then you'll know a thing or two about limits by now. However, the way to get these limits, the way to reach the answer, might not be so clear to you if you simply watched my last video on the introduction to limits. It usually isn't at first, although many people grasp the concept pretty quickly, and it seems pretty basic to some people, and it should to you too after you have some practice with it. However, it's a little bit abstract, and you have to really do a lot of reasoning, a little bit of guesswork, but not so much as you go on in terms of solving limits. So in this video, I am going to work with a problem that I obtained from this textbook. It's Calculus by Michael Spivak. It's a very good textbook. I personally learned calculus through this textbook. It uses a lot of pure mathematics, but still very good, a lot of interesting problems. So I think this was it was the second problem on chapter 5. So many of the problems require the reader to do proofs, or maybe some more complex analysis of the problem of limits themselves, but this one is fairly simple. Good. Now, there are a number of different things you could try, a number of different factorizations you could try, but the one that works, and I'll prove it in just a moment. I did this out before I started with this problem here, and a lot of this works, a lot of this is trial and error, but you can kind of make a guess for it. We have the limit as x approaches 2, and in the numerator we have x minus 2, because we're going to cancel that out with the x minus 2 in the denominator. So we have x minus 2 here. So we have x minus 2 there. And then x minus 2 in the numerator is being multiplied by the quadratic x squared plus 2x plus 4. And to prove this, we can multiply it out. So here we have x minus 2, and this is separate from the limits problem. I'm simply proving to you that this the numerator multiplies out to equal our original numerator, which was x cubed minus 8. So we have that, and we have this equals, well, we simply multiply every term by every other term. This is basic algebra, or, well, algebra 1 and algebra 2, but we have x minus x squared is x cubed, x multiplied by x squared is x cubed, x multiplied by 2x is 2x squared, x multiplied by 4 is 4x, and then we multiply the negative 2 by every term. So we have negative 2x squared minus 4x, and then minus 8. So now we have to cancel out terms. So we can cancel out these two terms, and we cancel out these two terms, and we are left with x cubed minus 8, which was our original numerator. So this works. Now what we can do is we can simply cancel out, as I showed in my last video, we cancel out the x minus 2, the numerator and denominator, and then this limit equals the limit as x approaches 2 of our remaining numerator, which was x squared plus 2x plus 4, and as you can see, this is much easier to work with. We don't have any contradictions like multiplying or dividing by 0, so we simply plug in 2. 2 squared is 4, 2 multiplied by 2 is 4, and 4 plus 4 plus 4, or 4 multiplied by 3, is 12. So our answer is 12, and the limit of this function as x approaches 2 is 12.